My name is Fluin. You may remember me from such keynotes as this morning. This is going to be a far more technically built workshop than what I just talked about, where I talked very abstractly about thinking Interchain, about all the cool ideas and ways we should collaborate. In this session, I actually want to show you real things that we can build, real things that we can do. So get much closer to the metal. If you just want to see the power of Axelar, then maybe this is not the perfect talk for you, but there is two places that I would send you. The first place is a place called Satellite. So this is a dApp that exists out there, and it basically allows you to create deposit addresses, send tokens between the various blockchains supported by Axelar. But one step even further than that, because when you think about Axelar, you should be thinking about us as a platform, is there's this really cool app out there called Squid. They're one of the exhibitors here. You're going to see a lot from them during the Interop Summit. But what they've done is they've taken and built the same sort of functionality that we built with Satellite, but they've combined it with DEXs. So you can both bridge assets and do cross-chain swaps all in like a single combined transaction, which actually looks and feels really cool. And like this to me is one of the purest, best manifestations of the power of the Axelar network. So who is this workshop for? So how many people here would you consider yourself a front-end dev of any kind? Okay, we got some JavaScript TypeScripters. How many people are smart contract devs? Or back-end devs? Okay, a few hands just for back-end devs. So for all of you that raise your hand, this workshop is definitely for you. Also, if you are interested in the technology and want to just kind of see how it actually looks like to feel and use Axelar, the various APIs, this workshop is also for you. Time. We have half an hour on the clock right now, which is not enough time to teach you to do everything possible. So I'm going to be going very fast. Kate's going to be going very fast a little bit later. If you want to get a little bit of a slower experience and actually dig into some of these things and maybe follow along in a little bit of an easier manner, we also have a workshop tomorrow where instead of just taking a half an hour to cover all of the APIs, I'm going to be taking a full hour and just be building kind of one full dApp that is this concept of what I'm calling an Interchain NFT, which I'll explain tomorrow. That's at 1:30 tomorrow. If you want to get deeper into this, if the things you hear today are interesting, definitely come by tomorrow as well. So the things that I'm going to walk through today is really just an overview of some of the primitives that Axelar gives you that are still an abstraction layer that are trying to make things easier for you as developers. And so I consider these currently in two categories. So the first is sending tokens. So if you just need to bridge some asset from one chain to another, we have a couple ways of doing that. We have something called a deposit address, which I'll show off. And we have something called send token, which is an on-chain API that allows you to do this. And then after that, we'll be taking a look at a second half of these, which is sending messages. And there's two types of sending messages. There's call contract, which again is an on-chain method that you can call to invoke and execute some remote contract on another chain, which is this kind of magical thing, which I get very excited about. And then there's also a version of that call contract where you can actually attach a token to that. So let's start with the send token side of the world. And I'm specifically going to go into this idea of deposit addresses. I'm going to be doing a lot of live coding today. I know I sometimes as an attendee get a little bit like, oh, I'm watching code scroll by that someone prepared. Good. I actually like seeing mistakes. So I'm going to make mistakes here and I'm going to show those off. Everything you're going to see here is going to be between Avalanche and Polygon, just to keep things simple. You could theoretically use any of the testnets that Axelar supports. So what is a deposit address? A deposit address is a tool that Axelar creates. Sometimes I call them like interchain portals, because effectively what you do is you encapsulate a source address, or a source chain, a destination address, and a token. You take those four parameters, and then that gets wrapped into a new address that we create on your source chain. And this ends up doing something very magical, because effectively any of the tokens that you send, any of that asset that you send to your deposit address that you just created will automatically be forwarded, paid for by the Axelar network to that destination address. So an example is, let's say I have Axelar USDC on Polygon and I want to send it to Avalanche. I create a deposit address on Polygon. I put whatever tokens into that address I want, and they'll automatically get forwarded, use the decentralized consensus of the Axelar network, and they'll show up on Avalanche. And so this is actually what I want to show off first. So we're going to go straight into live coding. Is everybody okay with some live coding? All right. Every time I mistype the word gateway, feel free to throw something at me, yell insults. It's all good. All right. So the way that we're going to start this one is because the get deposit address API is a JavaScript API, I'm going to start client-side local, and I'm just going to start writing some TypeScript. So You're going to see here we've got one of these IDEs. There we go. We have a very, very simple NPM package that I've created. It's got this README of what I did to get here. So I just installed a couple dependencies like TypeScript and the Axelar JS SDK. And you'll see those in a very, very simple package JSON. So what we're going to do is we're going to create a new file, and we'll just call it index.ts. So this is just a TypeScript file that I can execute. All of the code that I'm going to write here, you could run client-side in the browser. You could run server-side in Node. You can use TypeScript. You don't have to use TypeScript. Who here doesn't like TypeScript? Are there still people out there that don't like TypeScript? Okay. We should talk. I'd love to learn more. So the first thing we're going to want to do in our JavaScript or TypeScript code here in order to get a deposit address is we're going to do an import. So we're going to import a couple things, and let's make sure everyone can see this. Let's make it as big as we can. So we're going to import from a package called Axelar Network, Axelar JS SDK. So VS Code has automatically completed that just because I have it installed. And we're going to need three things. We're going to need the main object we're interacting with, which is Axelar Asset Transfer. We're going to need some environment configurations related to the testnet. And we're going to need some chain configurations. So Axelar Asset Transfer, environment, and chains. Let's see. Yeah, full screen never works for me on VS Code on Macs. But we'll just keep going here. Can everybody see this code okay? The rest of the code will be much shorter, so it shouldn't expand past the window. All right, so we've imported these things. So now we actually have access to the SDK. And the SDK is going to be kind of our magic. So we're going to save a version of that SDK. And we're going to get that from our Axelar Asset Transfer. We're just going to instantiate it and give it the environment that we care about. So this is environment dot, I think it's capital E. We did import the environment, yeah. Sometimes you can't trust autocomplete. Ooh, sneaky VS Code. What's it doing here? All right, I've already fat-fingered something. Well, we'll have prizes later for everyone that points out something that I've fat-fingered and can help me figure out what's going on. All right, we're going to keep going and figure that out in just a minute here. All right, so the four things that we talked about, we're baking all four of those properties into this deposit address. And so we're going to actually need those four properties. So I'm going to say const from chain is going to be equal to our chains.testnet.polygon. And then we're going to say our from to chain is going to be equal to chains.testnet.avalanche. Our destination address is going to be some random address. So let me just copy and paste one. Keep things simple. And then the last thing we need is the asset. So because deposit addresses are actually capable of crossing chain classes, so we talked about this idea in the opening keynote where it's better, it's okay to be able to do EVM to EVM, but wouldn't it be nice if you could do EVM to Cosmos? And this does support that. So you can do something like const asset equals UAUSDC. So this is the denomination that we use to indicate the Axelar wrapped USDC on those blockchains. All right, so that's our configuration. Now let's actually pass it into the SDK to get a deposit address. All right, so we're going to call the SDK.getDepositAddress address method. My autocomplete is not working, and so I've done something very wrong here. Oh, you're right. Thank you. See? We're going to get some swag for this gentleman. Perfect. All right, and hopefully that resolves this error in just a sec. Now we should be able to get deposit address, and we're going to just pass in all of those parameters. So we're going to say from chain, to chain, destination address, and the asset. Oh. That is what I meant to do. But like that, thank you. 2 pieces of swag? Do we even have 2 pieces of swag? All right, we get rid of some of our typos. So the one thing to know is that get deposit address actually returns a promise. And so I'm going to have to unwrap that promise. So I'm going to say deposit address dot then. We'll just do it on another line to keep things clean. And we'll just console log this out. And then we're going to say the address is all right, that should be complete our then, and we'll just add a little error handler that takes this and says error console.error. So one of the things that can happen in a network environment like this is that either the network doesn't work or there's too many people using Axelar at this conference. And so if we get a error 403, that is our gateway saying that there's too much traffic coming from this IP and we look like a bot. But we're going to brave on and give this a try here. So what I'm going to do is just find a terminal. Here we go. And we're going to run npx tsnode, and we're going to run our index.ts file. So again, you're not going to see a ton here. Either we're going to see an error from the network, and we'll just move on, or we're going to actually get a deposit address that any tokens you send to, whether that's me or anyone here, if you send USDC to that address, it will automatically get forwarded all the way to Avalanche. All right, there we go. That is now our deposit address. How many people want to see the next step of actually sending tokens to that deposit address? Can we skip that, or do you want to see it? Okay, we're getting a smattering of hands. Let's give this a try. So all I should have to do is find a wallet that actually has some tokens. It's terrifying typing crypto passwords in front of other people. All right, so all we should need to do is send to our deposit address. And let's send 2. Feeling rich today with all this testnet Axelar wrapped USDC. All right. And what will happen is if we actually take a look at that address on a site called Axelar Scan, we should see both the deposit address and then as soon as the network actually propagates. So you can see here is that deposit address registered within the Axelar network. And then as soon as that transfer actually goes through and gets processed by Polygon, you'll start seeing the transfers here. And you'll be able to monitor every step of the transfer. Success! Hooray! All right. Moving on to the second part of our little demo here. So what did we just do? So we just took a JavaScript application, used it to create a deposit address. You can imagine like lots of different use cases where you'd want to do this on the fly for different asset transfers. You sent tokens to that address, and it automatically got forwarded to a different chain. You didn't have to worry about paying for gas on Axelar Network. You didn't have to worry about paying for gas on the destination chain. That one transfer did it. But that was a JavaScript method to get that deposit address, right? So there was a bunch of like front-end work. But let's talk about back-end. Let's actually think about how a developer who lives in the smart contracts and is building these big complex dApps might do this. And so there is a send token method on the EVM gateways that we have. And again, it's going to take a very similar set of parameters. You might recognize these. So you've got the destination chain, the destination address, the asset, and the amount in the atomic units. So let's go ahead and build this. And the way that I'm going to do this is I'm going to jump into an editor that you probably all know and love, Remix. So let's just close all these out here. And I'm going to basically create a brand new contract. What should we call this contract? Anyone? Yell out a word. Interop. Interop.soul. Thank you. All right, we're creating a brand new contract here. We're going to paste in the dreaded pragma. I'm going to just copy and paste this because remembering which version of Solidity I'm on is not part of my job. There we go. All right, and now we're going to build our interop contract. Before I can actually create contract interop. There, we now have a smart contract. To make this smart contract interesting, we need to be able to allow our smart contract to interact with both the Axelar gateway and the token that we're interacting with. So we're going to go ahead and import all of the things that I need for that. So I am going to cheat here. I'm going to copy and paste the import statements. I hope you forgive me for not just memorizing these and typing them from scratch. But it's very simple what we just did. We imported iAxelar gateway, the Axelar gateway interface, from our GMP SDK. And I've just imported the OpenZeppelin ERC20 token. So this is an interface for ERC20 tokens, so we can interact with those contracts. All right, now that we have those things, I actually need a copy of those. And so what we're going to do is we're going to create some storage here to actually store that. So I'm going to say Axelar gateway is a public immutable, and we'll just call it gateway. And then we're going to create a IERC20 public immutable token. Okay, now that we have those variables declared as part of our contract, and I apologize, you can't see this. That's probably a little bit better. All right, so let's create a constructor so we actually are allowed to specify these things. So we're going to create a constructor, and we're going to take in two things. We're going to take in an address for the gateway, and we're going to take in an address for the token. So all we need to do now is take those addresses and assign them and create those variables. So we're going to say gateway equals Axelar gateway around the gateway address. And similarly, our token is going to be equal to an IERC20 around the token address. So does that make sense? We've just created a constructor, so when we deploy this smart contract, it's going to know about the Axelar gateway so that it can communicate on-chain. It's going to know about our token so that it can approve the moving of that token. All right, so now let's actually do something with the gateway. So I'm going to create a public function called send. And we're going to just define an amount. So I'll just create a uint amount, and I'm going to set it to 1 token in the right unit. So the USDC token, or AUSDC token that we're going to be using has 6 decimals. So I'm saying just taking 1 to the 10 to the power of 6. And now we're going to need to do 2 things. In order for these tokens to move to the gateway, we actually have to approve that spend. And so we're going to use that token contract, and we're going to say approve, and we're going to just take the address of the gateway, and then we're going to approve it in the amount that we specified here. And then the second thing is now we're actually going to call that gateway contract and ask it to send the tokens for us. So we're going to say gateway.sendToken, and what are the 4 parameters we're going to need? We're going to need the destination chain, so it's Avalanche here. We're going to need that smart contract address, or the wallet address that we want to send to. Send it to myself. We're going to need the, in on-chain EVM transactions, you don't use the denomination, you use the symbol. So we're going to say AUSDC here. And then the last piece is the amount. And with that, we have a smart contract. So when we deploy this, we're going to give it knowledge of where the gateway and where the token is on this specific chain. And then it's going to use this send token method to understand what's going on in the rest of the world. And you need commas after every parameter. That always helps. All right, let's double check our compilation. Looks good. So let's go ahead and deploy this. And so I'm going to take the gateway and the token address, and I'm going to deploy this. We should be on Polygon Mumbai right now. Perfect. And here's where we start praying that the internet works. So, oh, and you got to be, yeah, we're an injected provider. Maybe the mouse didn't just click. Oh, there it goes. Maybe I shouldn't have clicked it 6 times, but. Ooh, timeout. That is not good. Oh, did we actually get it though? Let's close this out. Let's try again. All right, this is I actually did a tweet about this the other day. The biggest problem with smart contract development right now is that all of the RPC endpoints are just unreliable, especially when you're coding live at a conference. So this should be all good. Kate or gentleman at the front, if you see what's wrong, let me know. What's that? Yeah, I just copied the gateway address and the token address. But it's not even, it's my deployment's not even working. This should pop up MetaMask and be like, hey, yeah, it's MetaMask. Do we switch RPC endpoints? I think we have a backup one here. Let's try that. All right, we're about to switch to the pull the completed cake out of the oven mode here based on the quality of these RPC modes. All right, we're going to pull the cake out of the oven the other way. So what we actually need here to do that so I'm going to pull up another copy of this contract first, give that a try. Oh, we're deploying the wrong contract. There we go. Silly us. You guys are all just silly gooses here today. Don't deploy the gateway contract, deploy the interop contract. I think it's alphabetical. We should have chosen a better name than interop. Something that didn't start with an I. All right, let's paste these in again. All right. And then let's actually do it on MetaMask. All right, we are still getting errors. I'm going to try one last Hail Mary of killing it and reloading it. And if that doesn't work, we'll move on. Oh, look at that. The old refresh the browser trick. All right, we're creating a smart contract now. Now, one of the things that I'm going to have to do is once that smart contract is deployed, I actually need to send it some Axelar USDC. So just like we did before, but this is not a cross-chain transaction. I'm just going to pick the asset and I'm going to send it one. So this is, again, I'm transferring my Axelar USDC out to my smart contract, and I'll just send one, because that's the amount it needs. As soon as that gets confirmed, what we'll be able to see is that this smart contract now has a balance of one USDC, and so it will be able to actually invoke that send token method. So this is the kind of full end-to-end magic of, this is imagine your dApp now being able to call out and send any token you want to anywhere you want, any destination. All right, so let's do one final blockchain transaction and confirm our send. And as soon as we get a transaction ID back, we should be able to pop that into Axelar Scan and watch, again, that end-to-end transaction that instead of this time me managing, I've actually built a smart contract that's managing all those interchain transactions. All right, there we go, transaction hash. Pop this into Axelar Scan. There it is. You can see Polygon to Avalanche, created a few seconds ago, one USDC. And again, you can follow along that entire path where it actually has to pay for the consensus on Axelar Network. It pays for the gas on the destination contract to deliver that token, all those sorts of things. But again, we're not going to wait around for that. All right, so what did we just see? We saw, thank you. We just saw deposit addresses, sending tokens via deposit addresses. We saw send tokens. The next thing I want to show just very, very briefly is call contract. So this is that interactivity where maybe you're not focused on tokens, but you actually want two of your smart contracts to interact between two blockchains. And in order to show you this, the easiest, best way is this GitHub repository that we've created called Axelar-examples. This has a ton of fantastic examples that will basically show you how to do anything with Axelar and give you the code necessary to get started. And so what we're going to do is I'm not going to spend as much time on this one. We're just going to CD over into the Axelar examples repo. And there's a fantastic README here. So if we take a look, here, let's just close out of this. So if you're ever curious how to use this, just open the README and you'll see very, very simple instructions about like run CI and then run build. And so it'll create private keys for you if you want. You can share your public key or your private keys with MetaMask or whatever wallet you want. And then the magic here is we're going to run npm run start. And this is actually one of my favorite things that I've ever seen in blockchain. And so testing interchain contracts is really complicated. You've seen in MetaMask, there's a lot of like, wait for the prompt, click on the prompt, all those sorts of things. And even if you're going to do this within Hardhat is fundamentally built assuming you have one blockchain. And so what we've done is we've actually created this local dev environment where that command I just ran, it spun up local versions of 5 different blockchains and then deployed all of the Axelar tools to that local environment. So you have this full simulated environment of multiple blockchains. So you can see we got Phantom, Ethereum, Polygon. So now I can just assume this is going to exist and I can do any sort of local development and do all the interchain communication that I want to do. All right, and then the other part that we're going to do here is we're going to do something called npm run deploy. And so deploy is just a script that exists within our Hardhat project here. And I'm going to say call contract. What this will do and you have to say local. It's now going to deploy the example executable sample to all of those blockchains, and then it will allow us to execute them in just a moment. And just to show you what's going on behind the scenes here, if you look in the examples folder, you're going to find this call contract. This is exactly the code we just ran. It's got a deploy method and an execute method. And this sample, it basically has, it's the full manifestation of call contract. Because there's basically 3 parts to calling a contract. You pay gas, so you pay to interact between any 2 contracts and any 2 blockchains. You pay for the gas in the source chain. That pays for it end to end. Then you call contract, and then on the destination chain you implement an execute method. So you call contract with a destination chain, destination address, and a payload, and then you get the source chain, source address, and the payload on the other end. So this is really, really straightforward. And so what we should be able to do now that we've deployed that smart contract is run execute. So initially the value of this contract on Phantom is blank, and as soon as the cross-chain execution completes, the cross-chain value is hello Phantom from Avalanche. So it's got a timestamp. It actually did that full end-to-end communication all locally in the simulator. All right, and I think I have one more thing, and then I'm going to hand it over to Kate. So we sent tokens, we sent messages. There's also this method called call contract with token, where it's identical to call contract, but instead, or in addition to a payload, you can attach a token. So we've got an example called send to many, where you pass over a list of addresses and a token, and then the destination contract will divvy out that token to all those destination addresses. And one more thing that I'm not going to have time to demo today, we actually have now support for Cosmos GMP in testnet status. So what this is the magic of not just being able to communicate between 2 EVM chains, but actually be able to execute interchain, right? So from an originated transaction on a Polygon, execute that on a Cosmos chain, like Osmosis. And to me, that's really magic. Take a look at this code sample. It works today in testnet. Give it a try, give us feedback. The one thing to know is that because Cosmos does not have the same concept of bytes, which is what a payload is in the Solidity world, so we actually have to do JSON wrapping of that payload. All right, and I think that is going to be it for me, and I'm going to pass it over to Kate.
All right, I'm going to fly through my demo. I've got 10 minutes. I've got my notes here to keep me on track because I will go off speech. All right, so native wrap and unwrap functions. What does this do? What do they look like? What do they mean? The biggest thing to understand is that wrapped AVAX is not AVAX. It's an ERC20 representation of the native asset, right? So for transactions where the user wants to send native tokens, say from an EVM chain, as we've seen here, a deposit address is generated that receives the native tokens. The implementation of Axelar's SDK then wraps the tokens into the ERC20 equivalent and then sends them to the wallet on the destination chain. The opposite flow would be for transactions where the user wants to send tokens back to the native EVM chain, where native tokens are sent to their wallets. The funds are first sent from the source chain to a swap contract on the destination chain. And Axelar's SDK then unwraps the tokens, delivers a native asset to the correct address. So, as we've seen, right, we call the get deposit address method on Axelar's SDK, and this takes in 4 parameters. From chain to chain destination address, which is recipient of the tokens on the destination chain, and asset, which is the asset in question. So here's the first of the 2 differences with this wrap and unwrap flow. The implementation of the SDK knows if you're passing AVAX by the keyword, and therefore knows it's the native asset. So you can swap out AVAX for any of the designated unique asset denoms that you want to transfer. These are all available in the docs. So for this flow, right, the contract on Avalanche will take native AVAX that the user deposits into their deposit address and convert it into the ERC20 equivalent, which is wrapped AVAX or WAVAX. Then it will transport that WAVAX to the destination chain. So the denom in this case is WAVAX way. Again, this is all, you can find all of these on Axelar docs. So basically they'll receive WAVAX from Polygon to their Avalanche address. So, quickly going to show you guys what this kind of looks like. So this is satellite, as Steven mentioned, this is our front end. So yeah, kind of contract view to what this looks like for end users. So this is on testnet right now. But basically, yeah, we've got Polygon to Avalanche, and we can choose wrapped AVAX and either receive on Avalanche wrapped AVAX or the native asset that is AVAX. So back to what this looks like kind of under the hood. Basically, this is the set of code that's called, right, for this function. So I want to send WaveAx on Polygon and receive WaveAx on Avalanche. Basically, the only change here is this Boolean toggle here, right? So Boolean toggle to receive WaveAx you see at the bottom is false. So for the second option, right, you're adding the Boolean toggle parameter to either keep it wrapped or to unwrap it, so it can go between true and false, depending on if you want to receive the wrapped asset or the native asset. The only difference really is this toggle. So should unwrap into native true or false. Pretty simple. So I flew through that because now we're getting into GMP Express demo. Yay! This should actually be full screen. This is GMP Express demo using Axelar examples repo. We're all going to hope that it works. If not, we're just going to talk about the code. All right. So the steps for using the Axelar GMP Express process is actually very similar to any other examples in Axelar's repo. So we are going to start with npm ci. Waiting for this. Waiting. Okay, cool. Next is npm run build. What this does is it compiles all of our Solidity. Cool. So this is what it should look like. So what is happening here behind the scenes? We'll just pretend that this compiled and ran perfectly and that, all is good. So basically, just like a normal call contract with token that Steven demoed before, the difference behind the scenes is that the 10 USDC being sent is actually being loaned by the Axelar network and then automatically paid back. So, where am I trying to go here? All right. Let me just pull up distribution exist.sol file. Where are you? Is this in here? Yeah, here we go. Got it. All right, so looking into the code, it's almost identical to the previous contract. However, there are some differences. So pay native gas. Let me make this. Come on. All right. So, let me find it here. Pay native gas call is updated to pay native gas for express call, which is, there we go. Pay native gas with express call with token. There's a bit of a premium to account for the express services lending. Then we call the contract with token, just like the original contract with token. Again, the signature is identical, but there's a little bit of a different gas payment. The other significant change is instead of being an Axelar executable, it needs to be an express executable. So, not seeing here. So yeah, an express executable. So this is what basically these are the two differences. So yeah, those two lines are the two differences on the contract side. The other complexity is that when you deploy it, if you want to deploy it via proxy, right? So the way that GMP Express works is that it's managed via a GMP Express service that exists on the blockchain, and then that GMP Express service needs to know where your contract is, right? So it can both know where to execute it, as well as enforce the payback of that loan upon resolution by the Axelar network. So yeah, you're not just deploying the Distribution Express executable contract, you're deploying it with this proxy, right? So instead of being deployed directly to the blockchain, you're calling the deploy express executable method on the service, and that creates a necessary proxy to enforce the repayment. So in the call contract with token method demoed before, this is just a smart contract, right? The Axelar network calls this as a smart contract directly. It calls the execute with token method, and then you're done. With Express executables, you deploy it via our Express service, which creates an intermediate smart contract that forces, again, that repayment of the loan once consensus on the network is reached. So normally, right, you initiate a call, goes to the Axelar network, the validator all, collectively vote this is truth. Then it creates a signature and forwards the tokens to the destination contract. The difference is we're not waiting for truth with GMP Express. You call the contract with token method without waiting for full finality. And this takes the transaction time way down to less than a minute. So basically, TLDR version is a GMP Express service is lending the token by calling the execute with token method, even though the network hasn't fully resolved the transaction. So basically, TLDR version, a little bit extended GMP Express. I have 10 USDC in source. I have, say 10 million USDC in GMP Express service. Call contract with token Express. This is the Express gas configuration receiver. 10 USDC on source is locked or burned. On destination chain, 10 USDC is loaned from GMP Express service to the destination. I'm getting beeped at. GMP Express service calls your contract. Axelar network waits for full finalization on source chain. Axelar network achieves consensus and mints or releases 10 USDC on the destination chain. The GMP Express proxy you deployed with pays back the 10 USDC to the Express service. And there we have it. It is also worth noting that this service is only available on an allow list. But if you want to play around with it, you want to learn more, you want to get on this list, yeah, definitely find us, talk to us, and we can talk about giving you access and helping you start to play around with it. So, I think we've got less than a minute. Steven, do you want to come back up and we can close it out? All right.
Well, we're actually out of time, so we'll just really just say everything you saw in the first half is live on mainnet, so including the native unwrap and unwrap. All that is just built into get deposit address. It's built into the send token capabilities. And GMP Express, if you want to check it out, it's live on testnet. And if you want to use it on mainnet today, it is available with an allow list, so come talk to us. Thank you so much. Have a great day, everybody.